Guys, I feel like this is the part that's going to take a little bit more time. So we're going to go ahead and go through this next part of the last part of our review, okay, which is going to be on operations of functions and composition and of course inverses, okay? All right, so the only problem that I will not do is going to be this one. Sorry, this is for both parts, this one and this one. So many arrows. These functions are for this problem and this one. The only one I will not be doing right now is this one because I did this example in class. Okay. All right. So I'm going to go ahead and draw a line to hopefully help you guys differentiate between the problems. Okay. These two functions, f of x and g of x, are for the set of operations of functions problems. These are going to be for the composition problems. Okay. All right. So starting with the first, I have f of x equals x squared plus 2x, and g of x equals 5 minus x. I'm looking for g minus f of x. So I'm subtracting the two functions, and I'm going to start with plugging in each of the functions. So for g, I have 5 minus x. I'm going to go ahead and put it in parentheses just to save my butt, just in case. Minus, right, because minus f. Okay, the f function is going to be x squared plus 2x. Okay, now this is where you guys are getting caught. Okay, because we have this minus sign, I need to distribute that negative to each of the parts inside the second half. The first part of this equation that I'm trying to find, so the 5 minus x, stays the same, so I'm going to go ahead and drop the parentheses. Okay, but now I'm going to apply this negative. So here I have this negative, and each of these terms, so the x squared and the 2x, are positive. So I'm going to go ahead and write a little positive right here so I can see the distribution that's occurring. So I'm going to start with the first one. I have a negative times a positive. A negative times a positive will give me a negative x squared. And a negative times a positive again will give me a negative 2x. Okay, so I went ahead and just distributed the negative to each of the terms inside the parentheses. Okay, you can also think of it as a negative 1, and a negative 1 times a positive x squared gives me that negative x squared. A negative 1 times a positive 2x gives me that negative 2x. Okay, all right. If this ever occurs, you can also just switch the signs for each of the terms inside. So because these are both positive, if I were to just switch the signs, they're now negative. Okay. All right, so let's go ahead and continue. The next step I'm going to want to do is combine any like terms. So I'm going to look for any like terms that I see. I have a 5 here, which is a constant. I don't see any other constants because each of the next terms have variables. Okay. Next up, I have x, a negative x, right? Okay. And I have a negative 2x. Now notice I didn't highlight the square, the negative x squared, because the exponent makes it unlike to this one. So remember, we're combining like terms. They are alike because they both have an exponent of 1 here. But because this one has an exponent of 2, you cannot combine them with these variables here. Okay, so I'm going to go ahead and combine, but I am going to want to put everything in order from highest exponent. So here I will have an exponent of 1. This is an exponent of 2 and an exponent of 1. Okay, so my highest exponent is going to be that 2. I'm going to start with writing down the Greek. So negative x squared. Okay, I'm going to go ahead and cross it out now that I've written it down. Next exponent would be this 1. Okay, now I know that it's hard to identify the exponent for the 5, but the reason that it is the lowest is because if you think about it, 5x to the power of 0 is the same as 5, okay? Because any number, any variable, any number, any value to the power of 0 is just 1. So 5 times 1 gives me 5. So the constants will always have the lowest exponent. Okay, so I'm going to go ahead and combine the pink here. Okay, I have a negative 1 minus 2x, so that'll give me a negative 3x. And last but not least, I have a positive 5. Okay, And this will be my final answer. All right. Next up, I have f times g. So now I'm wanting to multiply the two. So I'm going to go ahead and write down the f function, which is going to be x squared plus 2x, and it's going to be multiplied times the g function, which is 5 minus x. Okay. All right, now what we're going to do is we're going to go ahead and use FOIL. Okay, FOIL is going to stand for first, outer, inner, last. Okay, so starting with the first terms, I'm going to multiply the first terms of both factors here, both expressions. So x squared times 5 will give me a 5x squared. Now the outer terms, x squared times negative x, okay? Don't forget the sign. I have a negative and this one's positive. So that means that my outcome is negative, okay? And an x squared times x will give me x cubed. X cubed, okay? If we are wondering for an explanation of why it is x cubed, okay? On the side, I'm going to go ahead and write x squared times negative x, okay? Now I know you can't see it, but this variable has a power of 1, okay? Now when you are multiplying not polynomials, exponents with the same base, so they have the same base, x, when you're multiplying them, you add the exponents. So 2 plus 1 gives me that 3. All right. Next up, I'm going to have the inner terms. So 2x times 5 is going to give me positive 10x. Okay. And last but not least, I'm going to have, let me change this color to 1. All right, the last terms. So 2x times negative x. Well, of course, since it's a positive times a negative, my outcome should be negative. Okay. And here I have 2x times x, which is going to give me 2x squared. Okay. Now looking at the problem, I'm going to want to start highlighting the like terms. So I have 5x squared and a negative 2x squared. I also have a negative x cubed and a 10x. Okay. So the only like terms that I can combine are the 5x squared minus 2. So I will get a 3x squared. However, it is not the term with the highest variable. I do have this cubed, so that negative x cubed should go in the front. This is a positive 3 because I have a positive 5 minus 2 gives me a positive 3. And last but not least, I have a 10x. Okay, this is going to be my final answer. All right, I'm going to go ahead and move on to the next section. Like I said, I did this problem in class, so I'm going to go ahead and complete this one with you. Okay, now composition is when we're inputting one function into another function. Okay, so here's what I'm going to do. I'm going to rewrite each of the functions so that way you can see the movement between the two functions. So I have f of x is equal to x cubed plus 6, and I have g of x is equal to the cube root of 4x. Okay. Here, this f of g of x is going to be written like this, which means that we are plugging the g of x function into the f function. Okay. So the f of x function, again, is f of x equals x cubed, plus 6. Okay. So what I'm going to do is in place of x, I'm going to be putting the g of x function. So I'm going to go ahead and write this with big parentheses everywhere that I see an x. Okay, so I used to have an x here, right? Just like I have here. I used to have an x here. I just rewrote it with big parentheses. Now what I'm going to do is I'm going to go ahead and input this function here, but I'm only going to input part of it, right? Because I only want to put in the expression. I don't want to put in all of g of x. That's too much. All I need is this right here, okay? Everywhere that I see an x. Again, all I did was I plugged the g of x function into the f of x function, everywhere that I see an x. All right, now we're just simplifying. On the left side of the equation is just notation. We are not doing any math with this. This is just notation, like writing f of x. But we're saying that we are combining functions by plugging the g of x function into f. Okay, so this is just notation. On the right-hand side, notice that I have a cube root in parentheses to the power of 3. Now, if you know your inverses and your opposites is going to be, you're going to notice that you can cancel out this cube root and the exponent. They cancel each other out. If you look to the left-hand side, notice that I have this little graph over here that the cube root of x is the inverse of x cubed. So to undo any cube root, if I want to get rid of a cube root, I would cube both sides. And notice that's what was occurring here. Here I had a cube root of 4x, and then I had parentheses cubed. Okay, so lucky for us, that cancels out. I can bring down everything inside the house, the casita, which is the 4x. Everything else stays the same, plus 6. And that there is my simplified answer because there are no other like terms that I can combine. Right. Okay, so the next section, I did the first 2 in class, so I am going to do the bottom 2 with you here. Okay. All right, so a quick reminder that the inverse of a square root is a squared. So if I want to undo the square root, right, because sometimes I want to undo subtraction, so I add, okay, I'm going to do the opposite of square root, which is square. And it works both ways. If I want to undo the squared, I take the square root. Okay, same thing for cube and cube root. All right. So let's go ahead and get started. I'm going to work through each of the steps to make sure that I follow everything correctly. I'm going to start with step 1. Step 1 is just to replace f of x with y. So here I have an f of x. Instead, I'm going to write y equals 3x squared minus 1. Step 2 is going to be interchanging x and y. So they're just switching places. So I'll have x equals 3y squared minus 1. Now this is where it gets a little bit tricky, and I'm going to want to complete step 3, which is I'm going to solve for y. In other words, I want y completely by itself. I don't want an exponent. I don't want that 3. I don't want that 1. I want it completely alone. Okay. I'm going to start with reverse PEMDAS. Remember I talked about reverse PEMDAS in class. Okay. I'm going to want to go in the opposite direction. So start with any addition or subtraction. I have some subtraction here. So I'm going to go ahead and add 1 on both sides. I'll get x plus 1 equals 3y squared. Okay. Next, I have some multiplication here. So if I was looking at reverse PEMDAS, I cannot touch the exponent until I've already gotten rid of any multiplication or division. Okay, so here I'm going to go ahead and divide both sides by 3. You have to divide the entire thing by 3. You can't just divide 1 by 3 or just x by 3. It has to be the entire thing. Okay, that'll allow me to cancel out this 3. I'm going to go ahead and continue my work up here. That's what this arrow is going to be. So I'll have x plus 1 over 3 equals y squared. Now we're almost done, and if we look at our graph over here, if I want to get rid of the squared, I take the square root. Okay, so I'm going to go ahead and take the square root of both sides. Okay, that'll allow me to cancel out this squared and get y completely by itself. Okay, get y completely by itself. My fourth and final step is going to be to rewrite y as f negative 1 of x. So I'm going to rewrite it using my inverse notation. Right, all I'm doing is replacing that y. And that right there is going to be our final answer. All right, here is the next problem. I'm going to go ahead and start with step 1 again, which is just replacing f of x with y. So I should have y equals negative square root of x plus 2 minus 7. Okay. Step 2, still not too bad. All I'm doing is interchanging x and y. Everything else stays the same. They're literally just switching places. All right. Now, step 3 is where it does get a little bit complicated because I want the y to be completely by itself, and it's got a lot of stuff around it. Okay. Now, before we move on, I do want us to note that this negative, if there's not a number in front of this square root, we can assume there's a 1. Okay, so this negative 1 is being multiplied by the square root. Okay, again, if there's not a number in front, I can assume there's a 1. And this negative 1 is being multiplied by the square root of y plus 2. Okay, it's going to be important a little bit later. Okay, so if we're thinking about reverse PEMDAS, I'm going to start with any addition or subtraction. So I have a negative 7, and I also have this plus 2. But here's the thing about this plus 2. I cannot touch inside the casita. I cannot touch inside the casita until I've gotten rid of it. So I can't touch that plus 2 until I get rid of this casita. So we're going to get rid of everything else before. We're going to start with that negative 7 by adding 7 on both sides. So I have x plus 7 equals negative 1 times the square root of y plus 2. All right. Next step, okay, I have a negative 1 times the square root of y plus 2. I'm going to want to undo multiplication by dividing by a negative 1 on both sides. Dividing by negative 1. I'm going to go ahead and continue my work up here. So I have that x plus 7 over negative 1 equals the square root of y plus 2. All right. So this negative 1, what I can do is I can divide each part by negative 1 to simplify so I don't have this weird fraction. Okay. So here I have a positive x. If I have a positive x divided by negative 1, that'll give me a negative x. Okay. If I have a positive 7 divided by negative 1, it's going to give me a negative 7. So all I did here was switch the signs when dividing by negative 1. Right? It's going to be equal to the square root of y plus 2. Now I don't have a fraction. It's a little bit easier to work with. Now we're going to want to go ahead and take a look at our inverses again. So the inverse of a square root is a squared. So I'm going to want to square both sides. Okay. The squared allows me to get rid of the casita. So I can bring down everything else that is inside. Right? So I bring down everything else. Okay. Making sure that we put parentheses, because if you just put negative x minus 7 squared, I don't know if it's just the negative 7 squared. Is it just the 7 that's squared? What is squared? So including this parentheses tells me that we squared everything. Okay. All right, now we can go ahead and get rid of this addition using subtraction. I'm going to subtract 2 on both sides. Okay. So I'll have negative x minus 7 squared minus 2 equals y. Okay, now you might be asking, why is the 2 not being subtracted from the negative 7? Well, the reason is because with these parentheses, they're kind of like a house. They're a block. You cannot touch what's inside the parentheses, okay? So that negative 2 has to go on the outside. Our last and final step is, of course, very important. We need to rewrite using our inverse notation. Okay, and this is our final answer. Now, I hope this was helpful. Please use this time to complete that quizzes to the best of your ability and use these to your advantage. See you guys on Friday.